Good day, students. Welcome to class today. This is Samuel, the physics teacher as usual. And like I do tell you, please kindly subscribe and like the video so that you can get notification for new videos. That's just the reason. So that whenever we have new video, you will be notified. So, as you have seen, today we will be looking into specific heat capacity, and I will hopefully we are going to enter heat capacity to solve one or two questions on that. So, when we talk about specific heat capacity, let me share my screen with you. Let me share my screen with you. Sorry. Okay. Now, this is specific heat capacity. And when you hear the word specific heat capacity, you'll be like, what is specific heat capacity? Specific heat capacity of a substance is defined as the quantity of heat supplied or required to raise the temperature of a unit mass of 1 kilogram through a unit rise in temperature of 1 Kelvin. Okay, that is the temperature you need to increase the amount of heat you need to increase the temperature of a unit mass, just a unit mass. Okay, like 1 gram, 1 kilogram, and so on. To what? To increase the temperature of a unit mass by what? By 1 Kelvin. By 1 Kelvin through a unit rise in temperature, which is 1 Kelvin. Through a unit rise in temperature. Okay, now that's about that. And you can see we have this relationship between quantity of heat and the mass of an object and the increase in temperature. And this is the relationship which I'm going to show to you right now. Now we have quantity of heat required, which I'm showing you. Quantity of heat Q to be directly proportional to mass of the object, and the change in temperature, let's say theta 2 minus theta 1. Okay, we have that. We have that relationship. Now, looking at this, we realize that this, sorry, let me make. Okay, now looking at this, I like to divide my bar. Good. So we have this. Let's continue. This is quantity of heat which is directly proportional to mass of the object and the change in temperature, which can also be written as Q. It can also be written as Q, which is the quantity of heat, is actually proportional to what? To the mass, and we call this delta theta, which means change in theta, delta theta. Now, we need to introduce a constant. You know, going back to mathematics, we need to introduce a constant so that this proportionality sign will change to equal to. Then we can have something like this: say Q equal to C M change in theta. Cm change in theta. Now, this C is what we call the specific heat capacity. That is the specific heat capacity of an object, and that is what we have over here. You can see it here. Now we have C to be what? This is our C. C equals to okay, this is it over here. Q equals to MC theta 2 minus theta 1, or yeah. And where C is the proportionality constant, which depends on the material of the body. Okay, that is the C. It depends on the material of the body, and that is definitely the specific heat capacity of that particular body you are talking about. So, going back to this, let's continue. Let's complete what we started. Our C can be made subject to formula. So, for me to make the C subject to formula here, what am I going to do? I will say C equals to what? Q, which is quantity of heat, over M change in theta, which can otherwise be written as Q over M into theta 2 minus theta 1. And that's that about that. Now we've proven, or let me say here, we've now this is our specific heat capacity. This is the formula for specific heat capacity, which is C here. That is specific heat capacity. Without wasting our time, mind you, this specific capacity varies. You know, over here, I told you inside the note which I told you here, I said it that it depends on what? It depends over here. C is proportionality constant, which depends on the material of the body. It depends on the material of the body. And you can see over here that we have different specific capacity for different substances. You can see lead to be 130, mercury to be 140, brass to be 380, and then zinc to be 380, copper 400, iron 450, glass, aluminum, and so on and so forth. Then we have water, which is 4,200, sea water to be what? 3,100, and we have that of ice to be 2,100. 2,100. Now, what about the units? You know, one thing about everything we discuss in physics is that there is always a unit for all quantities, right? All quantities have unit. Now, our C will have this unit. Our Q is in joules because the quantity of heat energy, which is joules. All over, we have our mass, which is in kilogram. Sorry, the mass in kilogram. And we have our temperature, which is in Kelvin. So we can otherwise write it as joule per kilogram per Kelvin. Joule per kilogram per Kelvin. And that's that. Joule per kilogram per Kelvin. Okay. Let me make this. Oh, no, it's not going to work. Let's make this like this. Let's do this. Let's do this. Okay. Now that's that about that. If specific physical capacity is the quantity of heat required to raise 1 unit mass of an object, okay, a unit mass, then what will be the heat energy needed to raise the whole body? And that is what we call the heat capacity. Coming back to the note over here, heat capacity. Look at this. Heat capacity. The heat capacity of the body is the quantity of heat required to raise the temperature of the entire body through 1 degree rise in temperature, that is 1 Kelvin. Okay. Now the heat capacity is the entire heat needed to raise the temperature of the entire body, to raise the temperature of the entire body. Now coming back to this, if you are in need of, let's say, 2 naira, you are in need of 2 naira to buy a bread, a loaf of bread. Just a loaf, you know, all this your sliced bread. Let us know that you need 2 naira to buy a loaf of bread. And inside the ladle of bread, you're having, let's say, like 30 loaves of bread. You're having 30 loaves of bread. How much do you think it will cost you to buy the whole 30 loaves? You know, that is the whole package of the bread inside the ladle. Okay. If it costs you 2 naira to buy a loaf, how much will it cost you to buy 30 loaves? So let's say if 2 naira is for 1 loaf, then how much a naira will it cost you to buy 30? Now this our let's write this our okay this question mark. Let's yeah question mark. Now what you do is you cross multiply, right? And you say 30 times your 2 times 30 to be equal to your question mark times 1. And this will give you what? 60 naira to be equal to your question mark. Which means it will cost you 60 naira eh, to buy the 30 loaves. Now let's assume that the 2 we are talking about here is the, let's assume that this 2, the 2 here is the C, the specific capacity needed to buy 1 loaf. Okay, this 2 naira, okay, this 2 naira is the specific capacity needed to buy a loaf of bread. Let's say that, to buy a loaf of bread. Now, we're not looking for what? Its capacity, which will be enough to buy the whole bread. And what did you say? You just said your specific capacity, right? Multiply by what? Multiply by the whole bread. So this is where I'm going. For your eat capacity, which is H, simply equals to your specific eat capacity times the mass of the whole body. So we say our H equals to MC, and that's it. That is H equals to MC. Also, let me delete all this. We don't need them anymore. And this should come up like this. Now we have this, that's good. But as it is, remember that our C is equal to what? We have it over here. This is it. I said C is equal to Q over MC. Q over M into theta 2 minus theta 1. Okay. Now let us know that we want to substitute this into this equation. We want to bring all of this into this equation. So instead of writing our C here, we just put this. And what are we going to have over there? We are going to have something like this. H will be equal to what? Will be equal to M multiplied by what? Q over M changing theta. Q over M changing theta. Now, if you look at this very well, this will be, this M will cancel out. And what are we having left to be Q, which is quantity of heat over changing temperature. Or you can say theta 2 minus theta 1. So after this, what are we going to have? We can decide to make our Q subject of the formula, which is quantity of heat equals to what? Thermal heat capacity, which is thermal capacity, multiplied by what? By changing theta. So you can also have that formula. You can also have that formula. I'm just trying to give you some formulas which we may apparently need while solving, so that you won't be caught on that. Okay. Okay. Now, come on. This is done. Okay. I think this is nice enough. Let's go into some examples. Let's have 1 or 2 examples on this particular topic. Now, looking at this example, we have this question, and the question says, how much heat energy would be needed to change the temperature of 275 gram, 275 gram of paraffin oil by 75 Kelvin, by 75 Kelvin, and we are being given this as specific heat capacity of paraffin oil to be this 2130 joule per kilogram per Kelvin. You can see that you've been given this in kilogram, and you have your mass of sorry, and you, oh my god, can I bring that back? Hold on. Now you, sorry for that. Now we're back. So how much heat energy will be needed to change the temperature of 275 kilogram of paraffin oil by 75 Kelvin? And you'll be given the specific heat capacity for paraffin to be 230 joule per kilogram per Kelvin. You'll be given this as kilogram, while you'll be given this as gram. And you know that one thing we do in physics is we have to do what? We have to work with our units. Okay, so let me divide what is the two. Now, what are the parameters given? We have the mass of paraffin. Okay, we have the mass of paraffin to be what? 275 grams. But we can convert this to kilogram since you are working with this in kilogram. It will be 275 divided by 1000, and then our mass will become 0.275 kilogram. 0.275 kilogram. Yes. Then after that, we are done with the first stage. Let's move on to the next one. We also have our change in temperature. The temperature, they are giving us the change, not they are not giving us theta 1 or theta 2. They are giving us theta 2 minus theta 1, that is the change. The change is what? 75 Kelvin. Okay. Then we have the specific heat capacity of paraffin to be what? To be 2130 joule per kilogram per Kelvin. Now you are being asked to calculate heat energy, the quantity of heat that is required. Remember that your C is equals to what? Q all over M changing theta. If you look at this formula and we look at the parameters given in this question, we have this is quantity of specific heat capacity, and it has been given. Then this is quantity of heat. Is there anything like quantity of heat over here? No, we don't have the quantity of heat. What about the mass? This is mass. We have the mass over here. Then the change in temperature, which is this. So only this is what we don't have. Only this Q, which is the quantity of heat, or heat energy, quantity of heat energy needed. That is what we don't have. So we can easily make this subject of the formula. So let's say our Q will now become, let's make the Q subject of the formula. So Q now will be equal to what? Specific heat capacity times mass times change in theta, change in temperature. So let's continue. In that way, as our Q now will be equal to what? Will be equal to specific heat capacity, which is 2130 multiplied by 0.275 and multiplied by 75, which is the change in sorry please. that as well. Okay, let me write it anyway. Sorry for that. I think the system is so. Like I said, our Q will be equals to what's the C, which is 2,130 multiplied by uh, the mass, which is 0.275, 0.275, then multiply by, let me quickly review this, and multiply by what? Multiply by 75. Multiply by 75. Now, if you punch all this on your calculator, you'll be having your Q to be equal to 43,931.25 joules. So you can just approximate that to say 43,931, you can say 0.3 joules. That's the answer for that, and it is just as simple as that. Very simple. Now look at this question. Calculate the final temperature of 2 kilograms of alcohol, 2 kilograms of alcohol at 25 degrees Celsius when 20,160 joules of heat energy is added to heat. Specific heat capacity of alcohol equals to 25,000, no, 2,520 joule per kilogram per Kelvin, per kilogram per Kelvin. Without wasting time, let's swing into action. And the first thing, let me draw my line as usual. And now let's solve. Like you know, if it is the first thing we do is to itemize the parameters given. Over here, what are the parameters given? Let me say given. The first thing says calculate the final temperature of 2 kilograms. Mass is given to be 2 kilograms. What else is given? Of alcohol at 25 degrees. You have a temperature. Let's say temperature 1 to be 25 degrees Celsius. Okay. And when you're now given 20,160 joules, that is quantity of heat of energy, that is heat energy. Our Q is going to be 20,160 joules. 20,160 joules. Okay. And what else do we have? Then we have the specific heat capacity of alcohol, that is C. We have C of alcohol to be given as what? 25,250 joule per kilogram per Kelvin. So that's all. And what we have been asked to calculate is the final temperature, which will be theta 2. Theta 2 is what we have to find. Okay. So let's think of a formula that have all these. Remember our C equals to Q over M into theta 2 minus theta 1. Okay. So over here, we want to make our theta 2 solid of formula because if we look at it, we have the specific heat capacity given here. We have the Q is already given here. We have the M given as 2 kilogram, and we have the theta 1 given as what? 25 degrees Celsius. So the only thing left for us is what? Is theta 2. So that's what we have to find. And let me reiterate this to you. When you're using any formula to solve, there must be only one unknown. There must be only one unknown. Okay, so let's continue. Let's say we have this multiply both sides by m theta. That would be c times n in the bracket of theta 2 minus theta 1 equal to q times n into bracket theta 2 minus theta 1. Sorry for that, actually. All over what? All over your n into bracket theta 2 minus theta 1. Then all this, we cancel all this. And we'll be having, let me make this smaller a bit. Okay. Then this can become this and this. Okay, this is moving so. Okay, so we have this. Let's leave this like this and let's continue. Now, what are we left with? We want our, let's divide both side by m, divide both side by m, and by c rather. This will be c times m into theta 2 minus theta 1 all over c should be equal to what? Q over c. Then c cancels c. And we can also divide both sides by n. Divide both sides by m cancels m. We also be adding m here. And what will you be left with? Once that is done, you'll be having you'll be left with this. You'll be left with theta 2 minus theta 1 equals to q over n c. Remember that what we want to calculate is theta what? Theta 2. So we need to bring to find the means of taking this theta 1 to this other side so that our theta 2 will be left alone here. And you can see that we can add theta 1 to both sides, and that will be theta 2 minus theta 1 plus theta 1 will be equal to what? Q over nc, okay, plus theta 1. And this we cancel out. So we'll be left with what? Theta 2, sorry, will be equals to Q over MC plus theta 1. Let me okay, this one. So now let's substitute our value into it. So this will be Q2, sorry, theta 2 will be equal to, what's the Q? Q is what? 20,160, okay, all over 2 times 2,520, everything plus, theta 1 is what? 20, 25, 25. If you do this well, 20,100 divided by what? This will be 20,000, one, let me let's make it later. Okay, so this will give you theta 2 will be equal to 20,160 all over 2,500 times 2 will give you 5,040, everything plus 25. Now 10,160 over 5,040 will give you 4. This will be 4 plus 25, and that will definitely be 29 degree Celsius. And that will be our sorry. And that will be our T2, our theta 2. And that will be our theta 2. Now, if there's any question, please let me know in the comment section. Let me know in the comment section. For today, I will like to stop here. Okay. And if you have any question, please, you can drop your question or your comments at the comment section. Okay. Now over here, I have a few practice just to practice questions for you. Okay. You can solve these questions and others which you can get in your textbooks. For solve these two, I believe you'll be able to get it. But if you find it anything difficult or technical in this, get back to me and I will give you the correction and I will upload onto the channel. Thank you very much. Have a very nice day. Don't forget to like, subscribe, share with your loved ones. Tell your colleagues about this channel, okay, so they can learn at their own pace. So see you next class. Thank you.
I believe the knowledge is power to unlock inner potentials. Opportunity.